Hi and welcome to the Calculus CLEP review. In this video we're going to talk about the definition of a derivative. So what is a derivative? Derivative is the instantaneous rate of change at a particular point of a graph. Or in other words, the slope of a tangent line at that point. So if I have this graph and this point right here, if I want to find the slope of that tangent line, I first might try to do something like this. I got two intersections from that line to that graph. To find the slope of that line, now that's not quite right because I'm not close to the point, so I might try to go a little closer with that line. That's going to be a better approximation, but I want that even closer. So eventually I'll get right on a line where those 2 points, the difference between those 2 points is 0. Normally I need 2 points, but I'm going to get real close to it, so that difference between the 2 points is 0. I want to find that limit, and that's going to be the derivative at that point, which can be used to find the slope at that point. So the definition of a derivative is the limit is x approaches a of f of x minus f of a divided by x minus a. So basically finding the slope. That's our difference of the y values, f of x minus f of a, divided by the difference of the x values, x minus a. Now as x approaches a, that difference is going to be close to 0. So another way to write this is using h. We had a limit of h approaches 0 of f of x plus h minus f of x divided by h. So you're replacing the x minus a with h, which is the difference between our x value and another x value. So we want to find the limit as that approaches 0. And we can use this definition to find the derivative of a function. So the question asks, f of x is 2x squared plus 5x. Find the derivative of f of a. So basically we need to find the derivative of this function. So using our definition, so remember our formula, make a limit as h approaches 0 of f of a plus h minus f of a over h. Okay, so I'm just using a instead of x, so I can use either one, but I'm just using a in this problem. Alright, so we're going to have the limit as h approaches 0. And now I'm going to plug in a plus h into the equation, 2x squared plus 5x. So that's going to be 2 times a plus h squared plus 5 times a plus h. Let's put that in square brackets, showing it's all together, minus f of a, so minus f of a, so minus 2 times a squared, so 2a squared plus 5a. It's going to be all over h. Now we multiply the a plus h quantity squared. It's going to give me a squared plus 2ah plus h squared. And multiply out the 5. I get 5a plus 5h. Then I have minus 2a squared and minus 5a. I can distribute this 2, gives me 2a squared plus 4ah plus 2h squared plus 5a plus 5h minus 2a squared minus 5a all over h. Look at the top here, 2a squared minus 2a squared adds up to 0, so that goes away. I have 5a and minus 5a, so those go away. So now I'm left with 4ah plus 2h squared plus 5h over h. Okay. I'm going to factor out an h on top. Gives me 4a plus 2h plus 5 over h. And then the h's will cancel out. So I have a limit as h approaches 0 of 4a plus 2h plus 5. Alright, now at this point I can plug in 0 for h. So I get 4a plus 2 times 0 plus 5. That's going to leave me 4a plus 5. Okay, so that's going to be our derivative. And again, normally you see it as using x. So you can say it's 4x plus 5. Alright, so that's the derivative of 2x squared plus 5x. So this problem says find the derivative of g of x equals 1 over x squared using the definition of a derivative. So again, we find the limit as h approaches 0. We're going to do f of x plus h minus f of x over h. That's going to give me 1 over x plus h quantity squared minus 1 over x squared over h. So I have this fraction on top. In order to subtract fractions, I need to have a common denominator. So if I do that, I'm going to have x squared over x squared x plus h squared minus x plus h squared over x squared x plus h squared all over h. Now with a common denominator, I can rewrite it as x squared minus x plus h squared over x squared times x plus h squared all over h. And when I divide it by h, I can also rewrite it as x squared minus x plus h squared over h x squared x plus h squared. Now the top there becomes x squared minus x squared plus 2xh plus h squared over h x squared x plus h squared. And I can distribute that negative, so it comes x squared minus x squared minus 2xh minus h squared over h x squared x plus h squared. Look at the top here, we have x squared minus x squared, so those go away, leaving me with just negative 2xh minus h squared over h x squared x plus h squared. So here on the top I can factor out a h, so I have h negative 2x minus h, and then h on the bottom, x squared, x plus h squared, and then these h's can cancel out, leaving me with negative 2x minus h over x squared, x plus h squared. On the denominator, I can multiply that out to x plus h squared. It's going to be x squared, I'm just foiling here, plus 2xh plus h squared. And then distribute the x squared. Gives me x to the fourth plus 2x to the third h plus x squared h squared. Now from there I can't reduce any farther, so now I'm going to take my limit as h approaches 0 of negative 2x minus h over x to the fourth plus 2x to the third h plus x squared h squared. So I plug in 0 for h, this will go away. Down here times 0, make this whole thing 0. Also here, just make it 0 here, so it goes away. So I'll have negative 2x over x to the fourth. So I have an x on top and bottom, so those can cancel out. So it leaves me with negative 2 over x to the third. So our derivative of 1 over x squared is negative 2 over x to the third. So in this problem we have f of x equals 2x squared plus 2. Find the equation of the tangent line at 2, 10. Alright, so in order to find the equation of the line, we need a point and a slope. So we already have a point 2, 10. That's going to be where they meet. So 2, 10. We just need the slope of this line. Okay, from there we can find the equation of the line. So to find the slope, we need to find the derivative of the function at x equals 2. So we're going to find our limit as x approaches 2 of f of x, which is 2x squared plus 2, minus f of 2, which is going to be 2 times 2 squared plus 2, and there x minus 2, x minus a. Alright, so we multiply this out, we have 2x squared plus 2, 2 times 2 squared, 4 times 2 is 8, so minus 8, then minus 2, so you got to distribute the negative. That's going to be over x minus 2. If I reduce the top, I get 2x squared, so 2 minus 8 minus 2 leaves me with negative 8, and over x minus 2. Now if I factor out a 2 on the top, I have 2 and then x squared minus 4, and that's over x minus 2. Now if I remember my algebra, x squared minus 4 is the difference of 2 squares, so that becomes 2 times x plus 2 times x minus 2 over x minus 2. Notice we have an x minus 2 on top and bottom, so those cancel out. So we have 2 times x plus 2, or 2x plus 4. And I want to find the limit of that as x approaches 2. So we have 2 times 2 plus 4, or 4 plus 4, which equals 8. So our slope equals 8. We have point 2, 10. I can use my y equals mx plus b. My y is 10, slope is 8, x is 2 plus b, which gives me 10 equals 16 plus b. Subtract 16 from both sides. It's me negative 6 is equal to b. So we have our equation y equals 8x minus 6. Now we can take a look at a few example CLEP questions. So this question says if f is a function such that the limit of x approaches negative 3 of f of x minus f of negative 3 over x plus 3 equals 7, then which of the following statement must be true? So if we look at this, we have f of x minus f of negative 3, x plus 3, so that's really x minus the negative 3. So this is our definition of a derivative. So we're basically trying to find the slope of a line, the tangent line, at x equals 3 on f of x. If it equals 7, so that's our slope right there. And basically what that means is for our derivative function of negative 3, it's going to give us 7. So the slope of the tangent line at negative 3 is going to be 7. Okay, look at the answer choices. We get the derivative function of negative 3 equals negative 7, so that's not right. It shouldn't be negative 7. Then we have the derivative function of 3 equals 7, and it shouldn't be 3 because it's right here. This is our, our a value, so that's going to be of negative 3, so that doesn't work either. And we said it is derivative of negative 3 equals 7, so this is the correct answer. So the next one says f is continuous at x equals 3, and really we don't know. We know at negative 3 it is because it has a value, but we don't know at positive 3. And this says, and then E says f of x is equal to negative 3x squared, and they didn't give us the function, so we really have no idea what f of x will equal. So C would be the correct answer here. So this problem says that f be the function by f of x is equal to square root of 2x. Using a line tangent of the graph of f at x equals 8 was the approximation of f of 8.4, which would be the square root of 2 times 8.4, or the square root of 16.8. So here we have our function f of x is equal to square root of 2x. And I can rewrite this as quantity 2x to the 1/2 power. Now in this one, I'm not going to use a definition of a derivative, but to find the derivative of this, I'll move the 1/2 out front. And then reduce the exponent by 1. 1/2 minus 1 is negative 1/2. And then take the derivative of 2x, which is just 2. Okay, that's using the chain rule. I haven't gone over that yet, but that'll be in another video. Okay, so this is going to reduce to 1/2 times 2, so it goes away. So I'm left with 2x to the 1/2 power. Then when I have negative exponent, I can write it as 1 over 2x to 1/2 power. And 1/2 power is square root, so it really is 1 over the square root of 2x. That's going to be our derivative. We want the tangent at x equals 8, so I'm going to plug in 8 for x. It's going to be 1 over the square root of 2 times 8, or 1 over the square root of 16. It's going to be 1 over 4. Square root of 16 is 4. Alright, so our slope of our tangent line is 1/4. Now we need a point. We have x equals 8, but to find a point, go back to our original function, f of 8. It's going to be a square root of 2 times 8, or a square root of 16, or 4. So we have our slope 1 over 4, and our point 8, comma 4. Now we can find the equation of the line. We have y equals mx plus b. So y is 4, m is 1 over 4, x is 8, plus b. 1 to 4 times 8 is 2. Subtract 2 from both sides. We get b is equal to 2. So our line is y equals 1/4 x plus 2. Now if we want to approximate f of 8.4, we can use this line and plug in 8.4. Now this problem was from the non-calculator section. So what we need to do here is change our 8.4 to 84 over 10. And then we need to work this out by hand. That gives me 84 over 40 plus 2. We have two fractions, so we need to make those common denominators. We get 40 on the bottom, so multiply the top by 40 and give us 80. Add those together, gives us 164. I think this is 164 over 40. 40 can go into that 4 times. Gives us 160. So we got 4 left over, so 4 over 40, or 4 and 1/10. And in decimal, that'd be 4.1. So we can approximate 8.4 by using the tangent line and plugging 8.4 into that tangent line. So using our tangent line, 8.4 to be pretty close to that graph. Okay, you might have a slightly different equation of the tangent at 8.4, but it's going to be pretty close to the tangent line at 8. So the answer here is 4.1. So this problem says, what is the limit as h approaches 0 of sine of pi plus h minus sine of pi divided by h? Now if we look here, this is our definition of our derivative. F of x plus h minus f of x over h. So what are we trying to find here? We're trying to find the derivative of sine of x as x approaches pi. Now there's a list of derivatives that you need to basically memorize. So derivative of sine of x is cosine x. Derivative of cosine x is negative sine x. Derivative of tangent x is secant squared x. Derivative of cotangent x is negative cosecant squared x. Derivative of secant x is secant x tan x. And derivative of cosecant x is going to be negative cosecant x cotangent x. So basically here, our f of x function is sine x. We got that from what we saw here. The derivative is going to be cosine x. And we want to know as x approaches pi, what is x going to be? So basically doing cosine of pi. You got your basically your unit circle. We got 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi. So right on pi, your cosine is going to be -1. So it's going to be equal to -1. So this problem says, For some constant c, the line y equals 6x plus c is tangent to the graph of the function f of x equals x squared minus 1. What is the value of c? So for this one, you need to find the derivative. And the derivative of x squared minus 1, remove the 2 out front. And have x, and reduce the exponent by 1, 2 minus 1. Reduce the exponent by 1, so 2 minus 1 is 1. So the derivative is 2x. Now looking at our line, y equals 6x plus c, our slope is 6. So using our derivative, 2x equals 6. Solve for x, divide by 2, x equals 3. So that means that x equals 3, the slope of the tangent line is 6. Now if we find the point at x equals 3, it's going to be 3 squared minus 1. It's just using our function here. Or 9 minus 1, which equals 8. So we have 3, 8. Then we can use our y equals 6x plus c. We need this point 3, 8. So it's going to be 8 equals 6 times 3 plus c. Or 8 equals 18 plus c. Subtract 18 from both sides, gives me negative 10. It's equal to c. So in this problem, we had to use our knowledge of tangent lines. We have some graph. We have some tangent to the graph. Okay, that gives the equation to this line. The tangent line is 6x plus c. So we know the slope of the tangent line is 6. We find our derivative, which was 2x. We set that equal to 6. We can figure out what x value this graph has, where that point is, which was 3. Then we can plug in 3 into our function and get 8. Okay, so that's going to be that point. We know this line also has this point, that's where they meet the graph. And we can plug that point into that line and then solve for c. Thank you for watching this video, and I hope this helped you understand the definition of a derivative. Thanks.